chemistry lecture. This is very interesting chapter as it deals with how chemistry can reduce pollution and protection of our environment. Now this lesson is important as it deals with our environment and to be one with it. So students, let us start with our today's topic, that is green chemistry and nano chemistry. Now, due to increase in the human population and the industrial revolution, energy crisis and environmental pollution are the major global problems. Now, to minimize the problem of energy crisis and pollution, we have to adopt green chemistry. So, when we talk about why we have to study this green chemistry, in our life, chemistry plays a very important role in improving the quality of our life and the way of living. But as we have achieved more, but it has led to threatened to our environment and also to our health. The concept of green chemistry was put forth by Paul T. Anastas. Now this deals with that how chemistry can be used to reduce the effect of pollution and its effect on human health and environment. Now students, we can develop such chemical processes and our earth friendly product that will prevent pollution. This practice of green chemistry can create alternative to hazardous substance and design such chemical processes to reduce waste. Now this green chemistry is the use of chemistry for pollution prevention by environmentally conscious design of chemical products and processes that reduce or eliminate the use or generation of hazardous substances. Now this green chemistry deals with the use of chemistry to design and optimize the process and the product to lower or to remove the toxic substances. Now this sustainable development is development that meets the need of the present without compromising the ability of future generation to meet their own needs. Now when we talk about sustainable development, it's the organization of principle for human development and to make a better use of resources and protect the environment. Now let us see about the 12 principles of green chemistry. Here, scientist Paul Anastas put forth the 12 principles of green chemistry to reduce the impact of energy crisis, pollution, and to save natural resources. Now the first principle is the prevention of waste or byproducts. To give priority for the prevention of waste rather than cleaning up, and threatening waste or treating waste after it has been created. Now here we can say that it is better to prevent waste than to treat or to clean it after it has been created. Example we'll see over here. If we take the ash from the thermal power station, this can be used as a raw material in cement and bricks industry. Wastewater from cleaning of machine parts, this can be used as a coolant water in the thermal power station. Now when we see about the second principle is, so the first principle of the green chemistry states about the prevention of waste or byproducts. So here, to give priority for prevention of waste rather than cleaning up and treating with waste after it has been created. Now let us see about the second principle, that is atomic economy. It's the amount of atom in the starting material to that present in the product at the end of the chemical process. Now this atom economy is to generate less waste so that all the material used in the process get completely converted into product. Now, if we talk about percentage atom economy, it is, you will see the formula, that is formula weight of the desired product upon sum of formula weight of all the reactant used in the reaction multiplied by 100. So this gives the measure of unwanted product formed in the particular reaction. Now let us see about the example over here. Now suppose if we take butane 1-ol and convert it into 1-bromobutane. Now the formula for butane 1-ol is CH3, CH2, CH2, CH2OH. That reacts with NaBr, that is sodium bromide, and H2SO4. This reaction gives 1-bromobutane, that is CH3, CH2, CH2, CH2Br, and NaHSO4, that is sodium bisulfate, and water. Now here, if we want to remove percentage atom economy, then we have to take mass of 4 carbon plus 9 hydrogen plus 1 bromine atom upon mass of 4 carbon plus 12 hydrogen plus 5 oxygen plus 1 bromine plus 1 sodium plus 1 sulfur atom multiplied by 100. So here we know the atomic mass of carbon is 12, that of hydrogen is 1, and atomic mass of bromine is 80. So here we have to put all these values over here. You can do the calculation and see. Again, for oxygen, you have atomic mass which is 16. For bromine, atomic mass is 80. So put all the values over here. So you will get 4 multiplied by 12 plus 9 multiplied by 1 plus 1 multiplied by 80 upon 4 multiplied by 12 plus 12 multiplied by 1 plus 5 multiplied by 16 plus 1 multiplied by 80 plus 1 multiplied by 23 plus 1 multiplied by 32. The atomic mass of sulfur is 32. So put all the atomic mass over here, and after calculation you will get 137 Dalton upon 275 Dalton multiplied by 100, and here you will get percent atom economy as 49.81%. Now let us see about the next principle. This principle is less hazardous or toxic chemical synthesis. Now the chemical process should be such design that it avoid formation of hazardous waste. Now here, so we can say that for controlling the disease like typhoid and malaria, dichlorodiphenyl trichloroethane, that is DDT, was used, but due to its harmful effect on human, it is no more used. But today we are using benzene hexachloride, that is BHC, is used. So those methods of synthesis should be avoided that are toxic to human and environment. Now let us see about the fourth principle, that is designing safe chemicals. The principle states to develop products that are less toxic or requires less toxic raw materials. Now here, safe chemicals should be designed that are not toxic to the workers working there or to the environment. Now here, let us see about one example. Suppose benzene, which is a carcinogenic, that is, it can cause cancer, and volatile organic compound is used in the synthesis of adipic acid, but benzene also pollutes air. Now this adipic acid is enzymatically synthesized from glucose. So according to this principle, the product should be such design that are not toxic. The next principle is use safer solvent and auxiliary. Over here, in the step of reaction, use the safer solvent, minimize the total amount of solvent and auxiliary substances. So this auxiliary substances, it means that there are those substances or material that are not crucial but makes the product better for use. Now use of toxic solvent affects the workers. Many solvents are used in greater volume and many are volatile organic compounds. So there should be use of green solvent so that it is not toxic and it does not cause harmful to any of the workers which are working over there. Now let us see about the next principle. Now the next principle talks about design for energy efficiency. Now here the chemical synthesis should be designed to minimize the use of energy. The reaction should be such that the required minimum energy the reaction should be in a minimum energy and pressure. Here we should see that the use of proper catalyst, renewable materials or microorganism for organic substances. We can use the biocatalyst and improved technology for heating systems or microwaves for heating. Now, when such processes are carried out, there should be minimum utility of temperature and pressure. So, this principle it says about the energy efficiency. Okay, so whatever catalyst or renewable materials we are using, that should be working in minimum temperature and pressure. Now let us see about the next principle, that is use of renewable feedstocks. Now this principle states to use chemicals which are renewable. This renewable feedstock or raw materials are preferable to non-renewable ones. So here use of renewable or plants-based resources rather than crude oil should be done. If non-renewable materials are used, it puts burden on our environment. The product and waste should be biodegradable. Now let us see about the next principles. Now here we will see about all the 12 principles. So now we are dealing with the 8th principle, that is reduce devices. That is to minimize or minimization of steps. Now here we can say that unnecessary steps in synthesis should be minimized or avoided if possible, because such steps require additional reagents and can generate waste. Now in this principle it is clear that in the synthesis process we should avoid all the unnecessary steps that is used of better reagents and better chemicals. Now let us see about the 9th principle, that is use of catalysis. Catalyst in chemical reaction speeds up the rate of reaction and helps to increase selectivity, minimize waste and reduce reaction time and energy. So we are well aware of use of catalyst, that when we use catalyst it speed up the chemical reaction, the reaction becomes faster and the time required becomes lesser in less energy. Now let us see about the 10th principle. Now when we talk about the 10th principle, that is design for degradation. Now here the chemical used are designed such that they degrade and discard easily. Here students, the waste product should be degraded automatically to clean the environment. So biodegradable polymers and pesticides can be used. Now see the chart over here. Now students, when we talk about green chemistry, as we all know that chemistry has improved our quality of life and made thousands of products possible. But this all achievement has caused to human health and global environment a threat. That means they have caused a danger to our environment. Now all the synthetic chemicals from our industries, we know that they are toxic and carcinogenic. Nowadays our food, air, water, all are chemically affected. So it is approach of this green chemistry to design or to manufacture and to use such chemical products that reduces or it can eliminate the waste and make it safer for us. So here now when we see about the chart, that talks about the household plastic, which shows how we can sort plastic materials that we use in our daily life to recycle them and to make usable articles. Now students, see the first one in your chart. Here the PET or polyethylene terephthalate, that is used in microwavable food trays or soft drink and water bottles. Now this can be reused to make carpet, furniture, new containers and so on. Now see the second part in your chart. It is HDPE, that is high density polyethylene. It is used in household cleaners, that is household cleaning bottle, and in the shampoo bottle. This can be recycled to make pens, floor tiles and so on. Now in the third place we can see the PVC, that is polyvinyl chloride, that is used in the cooking oil bottle, food packaging and mouthwash bottles. This can be reused to make cables and roadways, gutters and so on. Now similarly, in the fourth, in our chart, the fourth place, you can see over there the LDPE, that is low density polyethylene, used in bags, carpets and furnitures. Now this can be recycled and reused to make floor tiles, envelopes and so on. Now in your chart, move to the fifth place over there. You can see in the chart, it is PP, that is polypropylene, which is used in ketchup bottles, medicine and syrup bottles. Now this can be recycled to make battery cables, brooms and so on. Now students, go to the sixth part of the chart. Now here we can see PS, that is polystyrene, which is used in disposable cups, plates and containers. Now this can be recycled to make foam packagings, insulations, rulers and so on. Now students, in your chart, go to the 7th part of it. Now these are all the remaining miscellaneous that is used in the food containers and nylon and other materials like that. Now this can be recycled to make more usable products. Now students, we can use this chart in our daily life to sort out plastic materials. This chart, which is present, we can see it on the big plastic containers. Even at our home or in the industries, we can see them. And this informs us how we can recycle different types of plastics. Now students, let us move to the next principle. That is the 11th principle, that talks about real-time analysis, pollution prevention. Now here, analytical methods need to be developed to allow or to permit real-time in process monitoring and control before hazardous substance forms. Now here, such analytical ways or methodologies should be developed so that continuous monitoring of manufacturing and processing is possible. Now let us move to our 12th principle. Now this 12th principle, it talks about the safer chemicals or safer chemistry for accident prevention. Now here, develop chemical processes that are safer and minimizes the risks of accident. So this principle, the 12th principle, it talks about chemical accidents that we usually hear about. That can be in the form of explosion, fire and emission. So we should try to minimize this by using the safer chemistry so that the accident can be prevented. Now let us talk about the role of green chemistry. Now students, as we all know that nature capacity to degrade waste and pollutions are limited. So innovative chemicals or innovative chemical technologies should be used to eliminate use or generation of hazardous substance. The green chemistry that we are studying now, this is to help to prevent pollution. It's a new way of looking at chemicals and their manufacturing processes to minimize their negative environmental effect. Now this green chemistry helps to protect the ozone layer. Now students, we have seen about the green chemistry, and so also we have seen about the 12 principles of the green chemistry. Now this green chemistry has been outlined to demonstrate how chemical products should be beneficial to human health and to the environment, and also bring efficient and profitable to us. Now this green chemistry processes tries to make our industry more efficient so as to consume less raw material and energies and to reduce the waste disposal. Now students, in today's lecture we have seen about the green chemistry, the 12 principles of the green chemistry. Students, so we should end up this lecture, and we'll continue further in the next lecture and see for the nanochemistry. So we'll end up over here. Thank you very much.